Assalamu alaikum everyone. So today we are going to start past paper topical questions of kinematics from the year 2024. Okay, so let's begin with the first question that we have. They're asking an object is projected from the horizontal ground as shown in the diagram, and it has an initial velocity of u and making angle theta. It's given here. And which statement does not describe the motion of the object? So what we have to focus on, not describe. Okay. So what this object is doing basically, if you see the initial velocity is u, angle is theta. So if I look at its components, this component will be the ux, and it can be written as u cos theta, and this component will be a vertical component uy, that will be u sine theta. And as we know, in the projectile motion, we have also discussed in the previous video that horizontal component will not change, it will remain constant, and the vertical component will keep on changing, right? So we have to choose the incorrect one. This is correct. The horizontal distance traveled by the object is tu cos theta. This is also correct. Why? If you use the equation s is equals to ut plus half at square, we know in horizontal a will be equals to 0. So if you use this thing, you will get the b. So b is also correct. The time taken for the object to reach the maximum height is t by 2. Okay, if you take t as the time of flight, the total time it spent in air, so if you take the half of that time, you will get the time at which it will reach the maximum height. Okay, in D, they are telling the vertical component of the object velocity is constant and has a value of u sine theta. Okay, this is true, but this thing is not true. Vertical component will not remain constant. So we have to describe that does not describe the motion. So D is the option that you will choose. Okay. So for the next question, a person travel on a motorway at a total distance of 200 kilometers. So, and then it traveled 90 kilometers at an average speed of this, which average speed must be obtained for the rest of the journey if the person is to reach the destination in a total time of 2 hours 0 minutes. So let's try to make the scenario first. So the person is traveling, let's suppose, from this point to this point. Let's name this thing, it's A, it can be called as B. This total distance is 200 kilometer journey. Okay, and the total time from this point from A to B that it can spend is 2 hours, right? So this is the condition that we have, and it's telling you that it traveled the first 90 kilometer at the speed of this. So first 90 kilometer, if I make, let's suppose this is the first, or this is the first 90 kilometers. So let's imagine this is 90 kilometer, and the speed here is it is, let's call it v1, that is 80 kilometer per hour. Okay, what we have to find, we have to find the speed, average speed basically, for the rest of the journey. Okay, so let's call it v2, that we have to find. Okay, so what we know from our previous knowledge, that average speed is equals to total distance divided by total time taken. Okay, so if I have to find v2, I have to find the distance traveled from this point to this point. So the distance will be simply, I can say d2 will be, the total is 200 and 90 was first, then it will be 200 minus 90. So it is 110 kilometers. Okay. So what I need, I need the time. Okay. So what will be the time it has spent here in this journey? Okay. Total time is 2 hours. If I can find somehow the time spent to travel this 90 kilometer, then I can find the T2 as well, because I know T2, let's suppose this is the total time, right? We know T2 will be equals to T minus T1. I need the T1. And if I apply the relation here that v1, that is the average speed, is equals to total distance traveled in this journey, that is 90 divided by t1. So it will give me, I know the value of v1 as well. t1 is equals to 90 divided by v1. So 90 divided by 80. Okay. So 90 divided by 80, if I calculate, it will give me 1.25 hours. So the time taken for point this till this for this 90 is 1.25. So what will be the time for the t2? So t2 will be equals to 2 hours minus 1.25 hours. So this time will give you 0.875 hours. Okay, so this is the time. So now we can substitute this thing into our basic relation, that total average velocity, total distance over time, distance was 110, time is 0.875. You will get 125.7, that is nearly 126 kilometer per hour. So the option is D. Let's move to the next question. The graph shows how a velocity varies with the time for a bungee jumper. At which point is the bungee jumper momentarily at rest, and at which point does she have the zero acceleration? Okay, so what we have to look at, if you see in this graph, the y-axis is representing the speed. Okay, so y speed will be zero at this point. So when the bungee jumper is at r, the speed is zero. It's pretty simple. You just have to look at the y-axis. So this is the point where the speed is equals to zero. Okay, if you see all the other points, this is the speed is somehow positive, and in these point the speed is negative. But it's not zero. This is the only point where the y-axis, the velocity of the speed, is zero. Okay, now you have to tell the acceleration as well. Zero acceleration. So we know slope of speed time graph will be equals to acceleration. So this is a curved line. So for a curved line, as we know, the slope will be a tangent to the graph, right? So if you see at the start, this is some non-zero slope. We have to look at the zero slope. This will also be some non-zero slope. But if you see at the Q, if you draw the tangent, it will be like this. So this is the zero slope. Okay, then again, if you move forward, this is negative slope, there is some slope. Okay, it's not zero, and then it can be zero at this point. Okay, but this is not given, this Q is given. So Q is the point where the slope will be equals to zero. Okay, so this is the point with the zero slope. How we know? By taking the tangent at point Q. So acceleration is zero at this point, so we will choose the option C. In the question 4, the graph shows how the acceleration of an object moving in a straight line varies with the time the object starts from the rest. Which graph shows the variation with time of velocity of the object over the same time interval? Okay. So we have to look at the acceleration time graph, and we have to convert that thing into the velocity time graph. So what we have to focus on first thing, the y-axis of the given graph is the acceleration, right? And the slope of this graph will tell you the acceleration. If I see for the whole journey, A is positive. It's not negative anywhere. It will be negative if the graph will be somehow in this region. Okay, but it's not in that region. So A is positive. So your slope should be positive. Here in this graph, slope should be positive. So if you see, this thing is negative slope, this is a negative slope. Okay, so we are not going to choose these options. Okay, and the next thing, if you see here, the acceleration is increasing, then acceleration is become constant, and then if you see the acceleration is decreasing. Okay, how you can check? You can check, let's suppose this is the point, the acceleration value will be somehow this. At this point the acceleration value is more, at this point the acceleration value is again less. So acceleration is increasing then decreasing. But if you see the D option, this is increasing slope. There is no decrease in there in D, so you can't choose the D as well. So we are only left with the option A. So A is the right option. Okay, how we can decode this thing, how we can relate both the graphs. So let's discuss this thing. If you see at the start, this is the increasing acceleration, so there should be an increasing slope. So if you see, this is an increasing slope, it's moving up. Okay, increasing slope. Okay, then if you see at the top, this is almost constant acceleration. So this is almost a straight line at the middle for a small portion. And then if you see, this acceleration is again decreasing. So slope should be decreasing. So there is a decreasing slope again. Okay, so A is the perfect fit for this thing. In question 5, a stone falls vertically from the rest. So we have the initial velocity, A resistance is negligible, it's mean A is equals to G. What is the speed of the stone when it has fallen through a distance of this? You have the S, you have to find the final speed. So what we can apply, the equation of motion, because acceleration is constant. So you can use V square is equals to u square plus 2as. This is the only equation of motion in which time is not involved. Okay, we have discussed in the last video how we can choose the equation of motion. So just put the values, v square is equals to 0 plus 2 into 9.81 into 0.40, and you will get v square is equals to, okay, to cancel the square root, you have to take, to square, you have to take the square root on both sides. So it will be 2 into 9.81 into 0.40. So that will give you 2.80 meter per second. 2.80 is option B. In question 6, a ball is thrown horizontally off a tall building. The ground is horizontal. Air resistance is negligible. Again, acceleration is g. Which statement about the motion of the ball is correct? You have to tell the correct. The acceleration of the ball is always at right angle to the path of the ball. No, that will be true if the motion is a circular motion. Okay, but in projectile motion, it's not always the case. So, and even this thing is thrown horizontally, so it will not be the case. At start, the ball will move like this, but eventually it will move like this, right? So this point, you can say the velocity is horizontal. Acceleration, obviously it's g, it's like this, but when it will reach this point, you see the acceleration is still like this. Okay, vertical, but the velocity is not horizontal now, it's a bit diagonal, right? And with the passage of time, it will move down and down more and more, so it will not remain 90 degree for the whole journey. So this is not the right option to choose. In part B, the ball follows a circular path until it hits the ground. It's not the case. The ball has a constant acceleration. Yes, the ball has a constant acceleration. Why? Because there is no air resistance. So you will choose the option C. Okay. And D is also not the case. If you see the equation, you can easily judge this thing. In question 7, a boy throws a stone with a horizontal velocity of 10 meter per second from the top of the building. So this is the ux, that is u. The height of the building is this is h. The stone travel a curved path until it hit the ground, as shown in the diagram as well. Air resistance is negligible, its main equation of motion can be applied. How long does it take the stone to reach the ground? You have to find the time. Okay, so what data we have? We have the horizontal velocity. Okay, so we have to find the time at which it will reach the point. Okay, so as it is launched horizontally, there is another information that we have, that vertical velocity initially will be 0. So if I have to find the time, I can apply the vertical, considering the vertical components, because all the data is in the term of vertical components, right? So I know that uy will be equals to 0, and acceleration will be equals to g, time you have to find, and s is also given. So now you can choose the equation very easily. S is equals to ut plus half at square. We will choose the equation in which final velocity will not be involved, okay, because it's not given and it's not be required, so it's irrelevant. So you will apply, put the values there. You will get 8 is equals to 0 plus half 9.81 and t square, so t will be equals to 1.27, that is nearly 1.3 seconds. So it's option C. In the question 8, two identical balls are projected vertically upward. Okay, so vertically upward, it's mean the initial horizontal velocity is 0 from the ground level with the same initial velocity. Ball X is in vacuum and ball Y is in the air. Okay, so X is in vacuum. So for X, acceleration is equals to G, and ball Y is in air. So acceleration will be less than G. Why less than G? You have to imagine the scenario. Let's suppose this is the X, this is ball Y. Okay, on X, there is only one, it's moving up, motion is upward, but there is only one force that is acting on it, that is its weight. Okay, this weight will cause acceleration. That is why A is equals to G. But if you look at the scenario of Y, there is one force that is acting downward, is weight. It's also moving up, the motion is up, so there will be another force, that is A resistance. Okay, so there are two forces because of which acceleration is caused. Okay, so sorry, its acceleration will be more than G. Okay, it will cause the more acceleration because there is a more resultant force, because A resistance and G both are involved here. Okay, so what we can say, we have to look at the options and we have to choose the correct one. Ball X reach a greater maximum height and in a longer time than Y. Okay, this is making sense why ball X will move much higher. Why? Because there is no A resistance in ball X, so it will reach a maximum height. Okay, in a longer time than the ball Y. Yes, it will travel further, it will travel more, it will cover more distance as compared to this one, because their acceleration is less, there is a more acceleration. Okay, yeah, deceleration you can say. It's just like this weight is acting like a braking force in the car. So if something is moving, you have applied the brake, that much brakes, but this thing is moving up, there is a double force of brake or something greater than the X. So when there is a more force, braking force, there will be a less distance it can travel and it can stop earlier, right? So A will be the right option for this case. Okay, you can also justify this thing by the equation of motion and by driving their relations, but I think this is more appropriate and quick to do, right? In question 9, an object is moving with the initial velocity of u. The object then moves with a uniform acceleration a for a time until it reaches the final velocity v. Which equation describes the motion of the object? Okay, so if you see the options, okay, there is one, the only B is the right equation. A, C, D, they're not the equations of motion even. Okay, they are incorrect. So it's very easy question to pick. Question 10. The diagram shows the path of the golf ball, which row describes change in horizontal and vertical component of the golf ball velocity when the A resistance is ignored. There is no A resistance, so if the ball is at any point, there is only one force acting on it, that is gravity. There is no force in the horizontal position, so only acceleration is vertical. So we can say that, as we have discussed earlier, horizontal component will remain constant throughout and Vy will keep on changing. Keeping in mind these things, you can easily pick the answer, that is option C. Okay. Question 11. An aircraft fly from London to the Sydney in a time of 21 hours 40 minutes. The distance traveled is this. What is the average speed? So average speed, it's very easy. Question is total distance divided by total time. Okay, so as if you see the answers, there are different units. So I will try to calculate the answer first in the SI unit, then we can justify in which unit it can be equivalent. Okay, so the total distance is 17,000 kilometers, 17,000 kilos. So kilo will be changed into meters, so that much meters. Okay, and for the total time, 21 hours 40 minute. So 21 hours, first I have to change in seconds. So 21 hour means in 1 hour there is 60 minutes, and in 1 minute there are 60 seconds, plus there is a 40 minutes as well, multiplied by 60, and the total will be in seconds. That will give you, let me calculate, it will be, above is 1760 and divided by 78000. Okay, when you calculate, it will give you 217.94 meter per second. If I look at the options, there is no option like this. There's one option in, if you see in meter per second, I got in meter per second, but they are not equivalent. So this is not the option. Okay, so how I can convert them? I can convert them into micro. If I convert this thing into micro is 10 power minus 6. So this will be 0.00 something, and I don't have any option, so it will not be the micro. Okay, this 10 power. So what I can do, if I look at this thing, the C option, 2.2 into 10 is to power 11 nanometer. So what I can do, it can be written, first write it in the standard form. It can be written as 217 into 10 raised to power 2 meter per second. Okay, if I try to fit the nano here, it will be 2.17, 10 power 2 is already there, and I am multiplying with nano. Okay, nano is 10 power minus 9. Okay, so if I multiply it with 10 power minus 9, I have to multiply it with 10 power plus 9 as well. Simple use of mass. If you multiply something, you have to divide it with something. Okay, you can do any action that can be cancelled with each other, so it will not make the difference in the equation. So I multiply with nano, that is 10 power minus 9. That is the reason why I am writing 10 power plus 9 by myself. So it can be written as 2.17 10 raised to power 11 nanometer per second. So it's option C we have. Okay, so it can be converted like this. If you try to convert this thing into the micro and milli, you will get the different results. So that is the reason why B and D cannot be the right options. Okay, in question 12, this statement is not correct. Okay, acceleration can be determined from the gradient of the velocity. This is correct. Acceleration is the rate of change of velocity. This is correct. Displacement can be determined from the area. It is correct. Velocity is the rate of change of distance. No, velocity is the rate of change of displacement. Speed can be a rate of change of distance. Okay, so D is not correct. Okay, it's in question 13, the diagram shows a laboratory experiment in which a feather falls from a rest. Initial is U. In a long evacuated, it means there is no air resistance. Acceleration is equals to G, and its length is L. Okay, so it takes the time T to fall from the top to the bottom of the tube. How far S the feather fall from the top of the tube in time 0.50 t. Okay, so basically there are two different scenarios that we have. Let's discuss both the scenarios. They are telling in first scenario that acceleration, it's falling downward, a is equals to g, initial velocity is 0, it traveled distance s, that is equals to L, length of the tube, in a time t is equals to capital T. Okay, this is the given thing. What you have to find, what they're asking you, that if all the conditions are same, a is equals to g, u is equals to 0, but the distance, how much distance it can travel, if the time given to it will be 0.50 of the previous time, that was capital T, that you have to do. Okay, and answer, if you see, they're also not the numerical numbers, but they are multiple of L, all of them. So you don't have to get the exact answer, you have to tell in comparison with each other. Okay, so if I do this thing, if I see here which equation I can apply on this, very easy to choose. It can be S is equals to ut plus half at square. Let's put the scenario what we have. S is equals to L, u is 0 plus 1 by 2, a is equals to g, and t is equals to capital T square. So I can write L is equals to 1 by 2 gt square. This is what I have. Length is equals to this thing. So if I try to solve the left hand side, this thing, same equation can be applied with the different conditions. We know S is equals to, in that case, we have to find U is 0, half A is G, and T is basically not capital T, but it's 0.50 of T, and there is a square on it. So when you simplify this thing, it will give you, I can write it as 0.50, there is a square on it, into 1 by 2 G T square. I'm intentionally writing it like this. It will not make any difference, right? Because all the things are multiplied with each other. So if you see this thing and this thing, so I know this half gt square is equals to L, so I can write as S is equals to 0.50 square into L. Okay, and if you find 0.5 square, it will give you 0.25 into L. So it's option B that is correct. Okay. Okay, so in the next question, a car travels along a straight horizontal road. The graph shows the variation of the velocity of the car with the time t for 6 seconds of its journey. The brake of the car applied for 1 second, from 1 to 4 seconds. How far does the car travel while the brakes are applied? Okay, while the brakes are applied. So it's mean from this point till this point you have to find. So you have to find the area under the graph. So if you see, there are two different shapes that I can make. It is this rectangle, okay, and there is this triangle. So you can find both the areas and you can add them. That will give you a distance travel. There is another choice that you can do. If you see, this whole thing is a trapezium, so you can apply the formula of trapezium as well. So area of trapezium is equals to 1 by 2 sum of parallel lines. This one and this one, they are parallel. This height is 22, its height is 8, so it is 22 plus 8 and multiply with the distance between the parallel line, that is 3. That will give you 45 meters. Okay, it's option B. In the next question, the diagram shows a velocity time graph for the object moving in a straight line. What is the displacement during the last 2 seconds of the motion? So last 2 seconds are here. It's again a trapezium, okay? Area of trapezium. So that will be 1 by 2 sum of parallel line, that is 6, and this line is 12. So 6 plus 12 multiply with the distance between them, that is 2. That will give you 18. It's option C. Moving forward to the next question, excuse me. A projectile is launched at an angle of 25 degree to the horizontal, with the horizontal component of velocity is this. You have ux. What is the vertical component of the velocity when the projectile is launched? You have to find uy. Okay, we know that uy is equals to u sine theta. Okay, so what we have to find, theta is given. Theta is 25 degree, but what is u? So that can be found by this thing. We know horizontal component is u cos theta. So u is equals to ux divided by cos of 25. So when you solve this thing, that will give you 14.34. Now you can put this value here. So uy will be equals to 14.34 multiplied by sine of 25. So that will give you 6.1 meter per second. It's option B. Okay, in question 17, a ball is released from the rest. Again, initial velocity is 0. At a time 0, at 1 second, bounces inelastically from the horizontal surface. Inelastic is the collision in which energy will be lost. Okay, energy will not be conserved. So, reaching the top of the first at this time, what is the total displacement of the ball from its original position x at time 1.5 second? This is the 1.5 second. Okay, if you look at this graph, this is not a, they're not asking about the distance travel, they're asking about the displacement. So displacement is a vector quantity. Again, if you see on the axis, this journey, if you, we know that the distance is the area under the graph. So this is the graph, this is the distance covered in one direction. Velocity is positive here. And on this side, the velocity is negative. So let's suppose I can say if something is moving like it's moving down, or let's suppose I can say it's a ball is okay. It's first it's moving down, it started from here, it's moving down. This was the time is equals to 0 second, and this is the time when it hit the ground when there is a 1 second. Now it's bouncing back, it's going up, not reaching the full height, but it will reach some point. There is a point 1.5 second. Okay, so displacement will be from this position till this position, the distance between the initial and the final point, right? So this is the displacement. So what you have to do, you have to find the area under this graph, this is this triangle, and this graph, and you can find the difference of this minus this thing. That will give you the displacement, that is this. Okay, so let's do it. The area for this triangle is 1 by 2, base is 1, height is 10, that will give you 5. Area for this triangle, that will be also 1 by 2, base into height, base is 0.5, height is 5. So that thing will give you 1.25. So 5 minus 1.25, that will give you 3.75. It's option B. Okay. In the next question, they're asking what is the definition of acceleration? Pretty easy question. Acceleration is rate of change of velocity. It's option A. In question 19, a basketball player hits a ball vertically downward with the speed of this. Okay, so do you have the vertical initial velocity? At a height of this, you have the S, A resistance variable, it's mean you have the acceleration, that is G. What is the speed of the ball when it hit the ground? So you have to find the V. Okay, so pretty easy. You have to choose the equation of motion. The V square is equals to U square plus 2AS. Just put the values here. You have 2.5 whole square plus 2 into 9.81 into distance is 0.90. When you calculate this thing, that will give you 23.418, but that is V square. You have to find the V, take the square root on both sides, so it will give you 4.83 meter per second. That is option B. Okay, so in the next video we will try to solve the kinematic questions from the papers 2023. See you in the next video.